Hello, hi. So after a couple of months, I'm back again with another episode. So I'm sorry, guys. I was away. I was very busy. Especially, I'm doing a project at home, and I will announce it hopefully very soon. What did I do with this project? But it's just as a sneak preview. I would say that it's something about the automation and cheap automation, especially with Raspberry Pi. But today I would like to talk about Raspberry Pi itself and the hats that are specifically built for Raspberry Pi and the problem that I have found during my working time with Raspberry Pi hats. There are different types of hats available in the market, but specifically I used one hat for stepping motors to control them, and I am really getting a lot of problems. So just as someone who has gone through this road, I got some experience that I would like to share with you. So let's discuss a little bit about Raspberry Pi and then the hat and find out what was the challenge that I actually faced. So let's do it. All right. So as I explained, I was looking for a hat for Raspberry Pi to control one-step motor, and the available boards for this specific task, mainly I could find two manufacturers. One of them was Adafruits. I hope that I pronounce it correctly. The other one was Waveshare. And so because Waveshare was cheaper, I actually decided to buy Waveshare and test it. But I'm actually not really happy with that because of the reason that I will tell you now. And so I just brought my Raspberry Pi. So this is the Raspberry Pi, and I hope you see it. This is the Raspberry Pi, and this guy is the Waveshare for the so for the step motor, basically. And the board itself is really clean and very clean, and I would say that it looks really nice, and the connection and everything works fine. um I mean, you have the opportunity, for example, there are some small switches here or here that you can change the stepping, like from 32 to the full step. uh, 32, it means that 1 over 32. So it means that amount of rotation per step over you will create pulses for each step. It will be divided to 32, so it would be more precise motion, I would say. But for my task, I don't need it, so I would put it to 0, 0, 0. So there are three parameters that you can change to create to define this 32 step. Um, but as I said, I don't need that high precision motion, so I put it to 0, 0, 0. This is one thing. Another thing is that if your motor, you have the possibility on this board to connect two step motor, and the connection basically, either you connect it through these two ports, the white ones, or you connect it from these green ports, basically, yes. And these green ones basically have four wires coming out of the motor, and you have to connect it based on sometimes up A plus, A minus, B plus, B minus, which is roughly the same, so minus, positive, negative. And so you have to connect these these wires correctly, and the rest is basically nothing. The rest is basically programming. um, there are also three I think three or four pins available on the GPIO GPIO, yes, which belongs to Raspberry Pi, and the connection or controlling of this board basically is through these pins. So for example, for this by the way, I have got this motor, NEMA, I guess, yeah, so similar with my name NEMA, but this one is NEMA. And the NEMA motors, they are powerful step motors. Usually you see a lot of these motors in 3D printers. They are all right. They are a little bit jittery, but they are all right basically for a cheap price. And yeah, so this guy I think takes 12 volts. I mean, optimal is almost 12 volt, and you can also apply more volt, I think up to 28 something. And it takes the board itself, I guess, I'm not sure how much ampere it takes, but I think there is a limitation up to 1.5 ampere, I guess, for each motor. So the thing that I realized is that if you keep the board for a long time on, it gets really hot. So maybe using a fan or something, especially for the controller, motor controller board, it's a good idea. And yes, so as I was explaining, if you want to control this one, with this board, you basically need controlling via the software. There are, as I said, specific pins that are made basically to create PWM, pulse width module, that you can define exactly how much the pulse is and how much the delay is, the cycle time, and also the frequency and everything about that to create these pulses. So for this board, as I said, there are 2 motors available, and the motor that I connected needs one pin for the direction of the motor, which should be used. The other one is the enable, that you enable this motor to be used. And the third one, the most important one, is the stepping. So the stepping, which are high frequency part of these IOs available on the Raspberry Pi. So yeah, so these 3 guys are the most important one. And then if you want to control this waveshare board with through the software, like the stepping, you can use also 3 other pins, I think 23, 24 and something, I don't remember. And you can exactly play the role of these switches that I showed you, these guys here. So you can also enable or disable and create the steps through the software. So that's the whole thing about this board that I wanted to explain you. And also it needs an external power supply for the motor itself, because you cannot depend on the power supply from the Raspberry Pi, because the poor guy does not have that much power. So you have to best supply power from the external supplier. Yes, so these are the most important ones. And if your motor requires a lot of current, you're moving something heavy, for example, then you have to use this potentiometer, I don't know what it's called. So these switches here to the maximum to get the maximum basically current, but don't do that. And so always leave some tolerance at the end, because it gets really hot, as I said. All right, so this was the hardware point of view. But what I found it very hard or not good was, honestly, I am using or programming this Raspberry Pi guy with CODESYS. I don't know if you have heard about the CODESYS or not. It's a very cool software for PLC programming, and my intention basically was modifying the Raspberry Pi to a PLC platform, which for cheap project is okay, but for real industrial project, I don't recommend it. It's I really don't know why, but I hope that Raspberry Pi version 5 somehow gets more industrialized. I don't know. I have not. This is Raspberry Pi 3, old one, very old. 2015, I guess this is. Yeah. But anyway, it is not reliable as a industrial controller. But for hobbies or whatever, I mean, like home projects, yeah, definitely go for it. And it's cheap. So let's go to CODESYS and find out why I don't like this board. So this is basically CODESYS, and I have connected the Raspberry Pi to the CODESYS through Ethernet, and I would like to just tell you that why this hat is not basically suitable, or at least what is the reason that I say that it is better to go for alternative of WaveShare. Because okay, the thing is that we are here, we have GPIOs. So and I click here, and yeah, just let's, like, for example, update this device. You see that you have two options. The option one is for old Raspberry Pi. The option two is for new generation or newer Raspberry Pis. So this one is the one that I actually taken, and I use this GPIO for B plus Raspberry Pi. And when you go inside, you will see a lot of things, like you will see GPIO's parameters. These are the GPIO that exist, and here you can define, for example, which one of these GPIOs are as a value, as input or as an output. If they are not used, so they are not used. But if they are output and input, you have to define them. So as I said, for step motor, for this specific step motor, I need at least 3 outputs. So GPIO 12, GPIO 13, and GPIO 19. I will consider them as, yeah, I will consider them as what? Output. So, and then I have the mapping. The mapping here is to define the address of channels, basically. So you have input channels and digital output channels. For us, the digital output channel is important because of the controlling the motor. So for example, the bits 12 that was defined as right here, okay, the bit 12 here is defined, or I have defined actually, as the step motor underline enable as a value or variable, number 13 as the direction, I guess, and number 19 I have to find a value here as a step motor underline step or whatever. This is the one, the high frequency ones. So basically both of these pins are high frequency. So you have to define everything here, the variables, and you will find this in the main program that you write here in the PLC, basically for the under the application. So this is working until now. All right. The problem is here that if you want to program this board, basically it's not easy. So there are some written libraries for step motors that you can find probably online on
CODESYS, which I will show you later. But basically it's working based on soft motion. And for soft motion, all right, I have to be honest here. I did not get the license for soft motion, so because it costs about 130 euro or something. So if you want to have the license for Raspberry Pi, it costs around 50 euro itself. But if you want to control and access, you have to also pay 130 euro or something for just for the soft motion. And this is actually a little bit too much for me at this moment. So the problem is that if I go here and if I go at a device and if I go here, position controlled drivers, I see these two libraries that, yeah, as I said, it was written by people in CODESYS. SM Drive Raspberry Stepper Direct and SM Drive Raspberry Stepper Pulse Direction. So the first one is for the DC motor and the second one for step motors. So if you select this one and add this device, it comes here. So far so good, right? So you have basically your drive installed and you have to go inside this, and then there are some parameters, values. So for example, the access type and limits. So let's say this is finite, and then you have to define the velocity that you would like, the acceleration, jerk, and everything here. And then you go here, you define the motor type, is it rotary or linear, and then you say that okay, for every motor turn, how much the increment is defined. Let's say for example 200. So every 200 increment will cause the motor to turn one, and etc. If you have a gearbox, you have to also define the relationship between your input and output, and if you have extras scaling, you have to define. And then commissioning, nothing here, and you go here. Here's some important stuff. And access reference motor setting, you have to define a maximum frequency. I don't know, let's say, I don't know, 1000. And then you have to define again the pulse system. A pulse system for me was, I don't know, 19. And the direction was, I guess, what was the direction? 13. And then enable, which was 12, I guess. I don't know. And yeah, so far so good, I guess. Number 18, there is a disable option, which we don't basically use it, I think. So this is yes. Let's go forward. Next, looks everything okay. So here, this is the status. But the problem, everything looks fine until now. So if I go to my main program, I've written some stuff which is not really related, I think. We can ignore. Let's go online. So I go here. I will have my, I guess I messed it up. Let's see if I can connect. Yeah. Takes some times. All right. So if I click this one and go to this run mode, you see two things. Unfortunately, when you are using GPIOs, the soft motion does not function properly. I don't know why. Why is that? When you use soft motion, you cannot use GPIOs. So if I go to GPIOs and if I go to the status, they say there's a message. The bus is not running. The shown values are perhaps not actual, which is the case. It's true. So whenever I use this block for controlling the motor, step motor, which is written, I cannot use GPIOs anymore. So it means that you cannot at all connect any kind of sensors to your GPIOs when you are using soft motion. Yes, so this problem exists, and it's very, yeah, nervous, I would say in German. I don't know what is in English. So yeah, it is embarrassing, I would say. So if you go to this drive, you also see, okay, you see that the license is missing or invalid. The PLC runs in demo mode. This is also something which, because I don't have license for soft motion. So basically, the moral story is that don't, yeah, if you don't want to pay too much, do not buy these wave share things. In the next video, well, I see, basically I don't have other fruit. Other fruit is actually this one. You see, I have opened it, but I don't have the board yet. As soon as I get it, I will test it, and I will show you in the video why Adafruit is much better to work, and instead of using GPIOs or soft motion, to use I2C, and why I2C is much compatible and easier to use for controlling your external motors. Yeah. All right. I hope that you enjoyed this video and short introduction. That's to go forward in the right direction. I will put this in my blog, and I will also explain another way that I try to control this with PWM option without any using of soft motion, but the result was not really satisfactory for me, even using this technique, creating a PWM block by myself. I will share it on my blog. If you have comments, I would be really happy to follow and hear from yourselves. And as soon as I get this Adafruit step motor board, I will update you what was the result. All right, guys, thank you so much, and see you in the next video. Bye.